Hi, 5th grade. Welcome to your tutorial on plate boundaries. It's me, Miss Syed, and special guest, Buffy the Bison. That's right, Buffy came with me to Canada so that he could be a part of our online virtual classroom experience. So today, we're gonna do a few activities to practice learning about the plate boundaries. So far this week, you've learned that the lithosphere is cracked. These are our tectonic plates, and they are floating on that ooey gooey mantle of called the asthenosphere. So that ooey gooey mantle, as it's moving, the tectonic plates, the lithosphere, is floating above it. There are three ways that those plates move, and I'm going to teach you a short little kinesthetic activity, you can call it a dance if you'd like, that we practice to learn the plate boundaries. The first plate boundary is convergent boundaries. So the word convergent means to merge or connect. So in order to show a convergent boundary, I want you to stick your arms out. Unfortunately, Buffy's arms are a little too short. I want you to stick your arms out so you can see your fists. Point your thumbs towards each other, and we're going to show a convergent boundary by coming together like this. Convergent. Let's practice that together. Convergent. A divergent boundary means going in opposite directions or separating from each other. So divergent would be the opposite, where you have your fists starting together with the thumbs pointing out, and that would be divergent. So convergent, divergent. Buffy's trying. Convergent, divergent. Our third and last plate boundary is called a transform boundary. Transform boundaries are a little different because they aren't moving together or apart. Instead, the plates are sliding past each other. A great example of a transform boundary is the San Andreas Fault in California. So to show a transform boundary, we're going to use our arms this time, like this, have them parallel to each other, and we're going to do a transform boundary showing the plates sliding past each other. So to summarize, we have convergent, divergent, and transform. To help practice, I'm going to have my cameraman help us out by shouting out a few he's going to shout out the three plate boundaries in random order, and I'm going to do them. You can follow along with me and we can practice together. Go ahead.
Divergent, convergent, transform, convergent, divergent.
Faster.
Convergent, transform, divergent, convergent.
Faster.
Divergent, transform.
Yeah.
Convergent.
Yes.
Transform.
Faster.
Divergent.
Yeah.
Transform.
No. Keep going.
Convergent.
One more.
Transform.
All right. If you can keep up with that, that will be great practice. We'll continue doing that together when we have our video call next week. In this demonstration, I'm going to show you the three plate boundaries just for your reference. There are two types of crusts that make up our lithosphere. We have the oceanic crust that we're going to represent in blue, and we have the continental crust that we're going to represent in green. Here we have a convergent boundary. There are two types of convergent boundaries. The first is when you have a continental crust and a continental crust moving towards each other. In this case, the two continental crusts start to come together, and as they come together, they get thicker and thicker so that they eventually form mountains. This is known as mountain building. The second type of convergent boundary is when you have a continental crust and an oceanic crust coming together. As a reminder, you learned before the spring break that continental crust is less dense and it's made of granite. Oceanic crust is more dense and it's made of basalt. Remember that basalt is more dense than granite. So that's why the continental crust always floats over the oceanic crust. That's why land is over the ocean floor. So to show this type of convergent boundary is called subduction. What's going to happen, and I might have to show this a few times, is that the continental crust and the oceanic crust are going to come together. As they come together, the continental crust floats above the oceanic crust literally sinks, and it's called subduction. It subducts. So we have an arch, sort of, with the oceanic crust sinking below the continental crust. Show that movement again. Subduction, it's a type of convergent boundary which happens when a continental crust and an oceanic crust come together. Earlier this week, I showed you this model where we have an oceanic crust on the right and an oceanic crust on the left. These are two separate plates that are separated in the middle, which is why we have a crack. At this divergent boundary, what you should know is that divergent boundaries occur when you have two oceanic crusts. In this case, the two plates start to spread apart. As they spread apart, the magma below from the asthenosphere begins to rise. As that magma rises and cools as lava, that asthenosphere turns into new lithosphere. This is the new younger rock. We have the older rocks on the sides, and it continues to spread as a divergent boundary. This is known as seafloor spreading. It is the reason that we have the mid-ocean ridge, and it is the reason why we have rift valleys. A transform boundary occurs with two continental crusts. In this case, we have movement where the plates are sliding past each other like this. It's not smooth at all. In fact, the rocks are basically scraping against each other. The San Andreas Fault is an example of a transform boundary where you have the North American plate and the Pacific plate sliding past each other, and this is very common we found where earthquakes occur. That is why a transform boundary is associated with earthquakes. So here is a brief summary of the plate boundaries and everything that's been discussed in this video. Please take some time going through this information. You might want to copy this down in a notebook or on a separate piece of paper to really practice and understand the plate boundaries.